All right. Hello again, everyone. We are back after a little bit of a gap there, but we picked a very inspiring day on which to return. It's Find a Rainbow Day. Now, if it lucks out here, we're getting a little bit of rain here today, but a little bit of sunshine too. I might be in luck, and hopefully you will be too. The construction industry is facing a workforce crisis that is comprised of availability, cost, and skill. For example, over 50% of contractors reported project delays due to workforce shortages, and over 90% of builders reported framing crew and carpenter shortages in 2022. Now, that's not today, that's 3 years ago. So imagine these things probably haven't gotten any better. Now, those shortages have contributed to an increase in the average new home construction cycle time to an estimated 8.6 months. Now, there is a solution to this, at least in the near term: advanced manufacturing and automated construction methods. Today, Sam Rashkin will discuss the current landscape of systems-built companies and the critical strategies that must be adapted for them to successfully scale. Now, in case you're wondering who Sam is, he's the creator and teacher of the Housing 2.0 content, which is based largely on Sam's latest book, Housing 2.0, A Disruption Survival Guide. The full program was established to help empower you, our building professionals, to design and construct higher performance, healthier, more sustainable homes at a fraction of the cost. Now, before all that, he was integral to the development of the Energy Star and Zero Energy Ready Home programs. Now, Sam's going to lead us through today's seminar and also address your questions at the end. Now, before we get started, we need to recognize our sponsors. The first is Panasonic Healthy Indoor Living Solutions. They're helping builders across the country differentiate themselves with powerful, code-compliant, and cost-effective indoor air quality solutions that provide a safer environment for home buyers. And we also have LG, who is a leading proponent of the electrification movement, and they're proud to pave the way with arguably the broadest portfolio of home electrification products. From air-to-air and air-to-water heat pumps for HVAC, water heaters, clothes dryers, and washer-dryer combos, to advanced energy storage systems, EV chargers, and super-efficient appliances, including the industry's first Energy Star certified induction cooktop. LG's innovation and technology will help us promote decarbonization and collectively create a better life for all. Now, during the course of today's presentation, you can submit questions for Sam. Simply use the Q&A function located in the menu bar at the bottom of the Zoom window. I'll review those questions and pose them to Sam after his presentation. Sam, you got any rainbows where you are?
Not today. Hey, thank you, Mike. And I'm like Mike, I could not be more grateful for our sponsors, Panasonic and LG. And I'm happy today to talk to you about a special topic very close to my heart, systems-built housing. So we're going to rethink, how do we scale systems-built housing? For decades and decades, it's been a big promise, but very short on meeting that promise. So today's going to be a really important topic for us. What we'll do today is we'll start with first a quick background on Housing 2.0. We'll dive into why systems-built housing, what's the basic driving reason why I believe it's so critical to the industry. What are systems-built homes, and why are systems-built homes not scaling? And then let's rethink how we can maybe change gears and get systems-built housing to truly grab a significant market share in this country. Now, don't believe that all conventional built home construction is going to go away. For mainstream production housing, that's where I believe system-built housing really critically needs to scale. So let's jump into the first topic, a quick background on Housing 2.0. Now, I always start with this very important data point about where do people spend their time. Substantial national lab research looking at hundreds and hundreds people surveyed found that we spend a whole bunch of time at residence, our homes, work, dining, outdoors, vehicle, and other indoor locations. But essentially, the takeaway that's so critical is we spend nearly 70% of our time every day in our home. Essentially, home is where life happens. Huge kind of point where you should feel really significant that you're involved in the housing industry. It's where people's lives happen. Now, post-COVID, I'll submit probably we're getting closer to 75% as we spend more time working at home, and that number keeps going up. So the key thing is, why Housing 2.0 then? The reason why it exists, the core fundamental reason why this program is so important is homes are going to happen better. Life's going to happen better with Housing 2.0. Homes where life happens better. And what we do is we provide a framework, fundamentals for consistently delivering a better user experience at lower cost. And so the key point I want to make is within that framework, of course, we advocate for high performance, sustainable homes. They're absolutely a must have. But like any five-legged stool, it wouldn't stand up. You need other legs. And so we have to optimize also the design, community, sales, quality. There are a whole array of consumer expectations that have to be met for the place where we spend 70% of our time. And the framework includes about 160 best practices. Now, how do we do it? And the first thing is asking people to do something they hate to do, which is invest more into the home, particularly into the user experience. Experts and special features that are a sure thing. We know certain investments will create a home that lives better. And so you see, we have two options, the lowest first cost option on the left and Housing 2.0 on the right, where we make an extra investment. But the secret sauce to Housing 2.0 is how we do it is by optimizing cost. And there are kind of 6 pillars for how we do that. Instead of excessive space, we optimize space so it's right-sized. And we live better with less space. Then complexity is incredibly costly, so we go simple. Non-integrated systems are incredibly costly and pervasive, so we integrate systems. Waste, of course, is by definition spending money on something that adds no value. So we go lean design and lean build to, again, reduce cost with no compromise in user experience and often better. Then we have way too much excessive customization in the housing industry. So we want to mass customize, and we have a tremendous lack of productivity. So we want to enhance productivity. With these 6 pillars, you have a net lower costs, therefore a cost savings. And because you've optimized user experience, you have all this added value for lower cost. So the key thing we have to do is the third step is translate that value. How do we translate these better homes for lower cost? And I will submit, if you go through the Housing 2.0 framework and all the details that we cover, somewhere about 30 to 70% greater value than a traditional home. Now, the key resource or the key thing I try to do is keep gathering empirical data how effective this framework is. One of the ones I had a pleasure of listening to at a conference was from Walsh Construction, a project where they built the first building on the site, which was a multifamily apartments. Then they built the second, but only optimized the design experience, most of the design, and they got 24% reduced costs from the first building with units that live better. So again, I love the empirical evidence, and your main resource is the book Housing 2.0, A Disruption Survival Guide. Has over 360 citations, tremendous amount of graphics. Again, for those that are interested in this, this is the best reference. So now let's jump into why systems built homes. And there are 3 key reasons why. One is the trade crisis, second is the productivity crisis, and the third is the affordability crisis. These 3 crises converging on the housing industry at this very time that we're living right now. And I don't think any of these are a surprise to anyone, but we'll cover them briefly. The trade crisis, and Mike covered a number of these points in the introduction, is one of availability, skill, and just training. And when we look at the surveys year after year after year, we see builders are struggling. 60% of builders expect cost and availability of labor to be a real problem in 2024 and 2025. And you can see right there on the survey, right, how significant that is. When it comes to also the trade crisis, 60% of builders reported framing crew and carpenter shortages in 2024. So that's more recent data than Mike gave you. There are carpenters and framing crews. So again, we still have way too many builders just trying to figure out day to day where they're going to find the workers. And then we have the impact on the work itself. 54% of contractors reported project delays due to workforce shortage. And this is a really much more recent survey from the end of last year. And the trade crisis itself has been calibrated a number of times. And the Home Builders Institute 2023 study had submitted that there are about 723,000 new workers needed each year to meet demand and combat the 1.5 million home shortage we have. Tremendous shortage of labor, counterbalanced by the fact that the workforce is aging. The average construction worker age, according to the Bureau of Labor Statistics, is over 42 years old. And there's no pipeline to replace them. For every two that retire, there are only five. For every five that retire, there are only two workers in the pipeline to replace them, and that's just going to compound the crisis and make it even worse. And again, this comes from the Home Builders Institute Labor Market Report. So that's the trade issue, and kind of a sister of the trade issue is the productivity crisis, and it's just incredibly severe. And I like to start first by showing visibly just what productivity innovation looks like in an industry. So we can look at how a car was first made in 1903, cobbled together in a back room by one person, and then of course by 1913, the big innovation, the Model T assembly line transformed production of cars. Productivity went up like 100x. And then you look at a production line today, and the amount of work produced by one person per hour is like, again, another 100x from what it was and used to be because of robotics and advanced production lines. So you look at the auto industry, and it's a stunning improvement in productivity. In the housing industry, we can look at a home being constructed 150 years ago. This is a picture I got from the archives of the Smithsonian, and compare it directly to how we build today in 2025 and marvel at the lack of innovation and how we build enclosures. Virtually, we're stuck with very unimpressive innovations, maybe balloon to Western platform framing, dimensional to engineered lumber, some power tools, and better connectors, but it is a stunning lack of innovation. And the outcome, of course, is predictable. Housing is the only industry to decline in productivity, 50% decline in home building productivity since 1968. And so that just will not get the job done when you have an affordability crisis. It's working against the other crisis and creating and compounding the ability to deliver more attainable housing. So on top of that, we see that because of the productivity challenges, the cycle time, the average time from start to completion for a home has now increased on average for the industry to 8.6 months. Production builders, particularly the big nationals, may do it in 3 months or 4 months, but it is incredibly slow in terms of what it takes to build a home. And again, because all these are connected, if there's a trade shortage and trade skill challenge, then you have a cycle time challenge that just follows suit. And so time costs money, and that's a real problem when it comes to affordability. And then on the productivity crisis, there have been other studies that have been done that simply look at when you have a given amount of resources going into producing a product, what percent is value added, non-value added, or just basic support activity. And housing compared to manufacturing is pretty scary. Only about 10% of construction resources really add value, and that's more than 6 times less than manufacturing. So just huge opportunities to improve productivity. And one of the big culprits is how poorly digitized the housing industry is. McKinsey and company did a study and quantified digitization across all the major industries. And but for agriculture and hunting, construction's absolutely the lowest. So when you look at the color of all the key assets and usage and labor factors that were looked at and how digitization works for the industry, they're almost all dark red or orange, which means hardly any use of digital technology. So this is really hurting productivity, and then it's hurting affordability. Everything's working together. When McKinsey and company in a separate study actually quantified for the entire construction industry, what does this lack of productivity cost? It was a scary $200 billion productivity gap that could be closed by adopting advanced manufacturing methods. Again, back to why is system building so important? We have to close that gap if housing is just getting crazy unaffordable. Which brings us to the last crisis, affordability. And I'll only show you one slide here because it tells the entire story. You can look at the bottom, the black curve is for median household income, and then look at the median household price. And this is scary. Now we're seeing kind of a trend. We have a big increase, and then we have a drop and a recession, and then we have an increase and a drop and recession, increase and a drop. Well, here we have the gray bars show the recessions, and here we are today with another crazy increase in the cost of housing, which is why many analysts predict some sort of correction and possibly a recession. And with all the turbulence going on now, there are many forces that may amplify this trend to happen once again. But the point is, this is not sustainable. A widening gap where the product gets ever and ever more costly relative to the resource available to buy it, the household income, at some point you hit a cliff. Now, all the distortions that are happening because we have a crazy amount of small amount of inventory when everyone's holding onto their homes to protect their low interest mortgages, or there's supply chain issues and we can't build as fast, whatever reasons, those distortions won't last forever. And this reality will kick in. 70% of US households cannot afford a medium price home, according to the NAHB, National Association of Home Builders. That's all you need to know about affordability. Something has to give. So what are systems built houses? And essentially, I'll tell you, they are a crisis-ready, off-the-shelf solution that could be applied to address these challenges in the industry. And again, a huge chunk of homes will still be built conventional, traditional construction. But for people who need to afford a house and can't, we need to employ this kind of innovation. And the 5 main options are kits, which are basically today mostly framing kits. The lumber is pre-cut and pre-made for the house. Various types of panels that are delivered on site that are made in a plant, framing, SIPs, structural insulated panels, insulated concrete panels or ICPs, precast concrete, which today is mostly used for foundations, modular, which are whole modules, fully finished or partly finished and dropped on site. And then there are hybrids of panels and modules mostly used for the very trade-intensive parts of the home, the kitchens and the baths. So these cores are dropped on and panels for the rest of the home. And then 3D printing, where you print in a factory or on site the home with the special equipment that can print using various materials, most commonly concrete or composites. And so now you have a tremendously reduced or mitigated need for trades. You have superior quality and cycle time to improve productivity. And affordability is huge from the time cost savings, both for operational expenses or running the business that are reduced by 30, 40, or 50 days times $500 or $800 a day. And velocity, if you're producing 50% more homes and you're making 20, 30,000 per home margins times 50% more homes, that could be hundreds of thousands of dollars additional revenue a month that can be used to reduce the cost of your product. And then less rework is cost savings, and tremendously less waste is cost savings. So this is why systems built homes are so important today. And let's just go through each of these options and see what they look like. But I just want to, again, explain where a lot of the cost advantage comes from on cycle time. The design and permits are the same for systems or site built, but with site built, you can only do lot development and foundation at that time by itself, where with systems built, the same time you're doing the site and lot development, the home can be constructed at a plant to be dropped on the site when it's ready. So then when you go to site built, you have to do all this construction on site, where systems built, you're just assembling the panels or the modules at a fraction of the time, and the site restoration is almost completely eliminated or substantially eliminated. This, by various studies, is about 30 to 50% time savings because of the simultaneous ability to build a home with the plant when the site's getting ready. And the numbers get to be pretty significant. If you're saving 30, 40, 50 days, and research tells us that it costs about $500 to $800 a day operational expenses for a builder, you're getting into real money, $15,000, $25,000 for 30 days, $30,000 to $50,000 for 60 days. And again, the average construction time today is 8.6 months. So let's look at the various different types of site-built options. Site-built's not new. Back at the turn of the century, Sears kit homes were available that were the entire home dropped on site, all the pieces inside, outside. Here's a home that from 1925 for $2,200. That was 30,000 pieces. You see how they are advertised in magazines. Here's an actual home today, obviously gone through many different probably upgrades and so forth, but it was amazing what was done at the turn of the century. Today, kits are mostly for framing packages. This is one framing package company where, again, you send your CAD drawings and all the pieces are cut and they are organized by sequence and how they're installed, and they're numbered so that you can't make mistakes in the field. E101 has to go next to E101 in the corners, and everything's made up so that you can't have labor. You take labor mistakes out of the equation, and then the labor can just assemble quicker because everything's stacked in sequence, ready to go. And so it's a big time saver. The next step up is panels. The most common panels are framing panels. Like here, you see the panels being installed on site, and some panel companies, particularly wood framing, will do both the inside walls and the exterior walls and the roof and so forth. And then you have some more advanced panel companies like Unity Homes has a very advanced high performance wall plant, and they make beautiful homes that are built on site. And so this is pretty well developed in the country in terms of the capability. We'll talk about scaling in a few moments. After conventional frame panels, there's structural insulated panels. They're elegant, they're simple, they're insulated assemblies that are just dropped on site. You have two skins, usually OSB, sandwiched and glued to the polyurethane core, usually extruded polystyrene or expanded polystyrene most often, sometimes polyisocyanurate. And again, you have the panels that drop in. They're quick, elegant, they're incredibly airtight. They're like having like a incredibly efficient blanket around you. They work so well. So I'm a big fan of structural insulated panels. Should be much more used than they are today. The insulated concrete panels are kind of a derivative of the insulated concrete forms. They're much less labor intensive. You have a whole panel instead of blocks. You pour the concrete in the core that you see in the panel on the left. One person can lift it and set it in place. You have these metal stirrups on the inside and the outside for attaching both the interior and the exterior finishes. And again, they're numbered, they're elegant, they go in fast, very simple, and the home's very airtight, very high performance, and very much faster construction. Then you have precast concrete, which is really amazing for foundations. It's about 5,000 psi versus 2,000, 3,000 psi poured in place on site, so it's more waterproof. You have all that more efficient use of the concrete, 70% less concrete because of that rib configuration that you see. And because of the metal stirrups that are attached to the end of the rib, you have fastening for your drywall, so you don't have to build a whole frame assembly to have a finished basement. It's ready to go. We have R10 insulation everywhere around the rib and in the cavity, and you can add more insulation in the cavity if you want, and it goes in faster, and it's just really an elegant way to do basements. It can be used above grade too. And this is a kind of a finished basement ready to go and have, again, this is a finished foundation ready to be a finished basement. Notice there's no footing, so you have much better flow of moisture from under the slab to the drain tile as well. And then you have modules that were built in the factory. Often they're pre-finished, sometimes not finished or partially finished. And you build these modules, and on site you drop them in place even faster, but more waste, using about 33% more material than you would for traditional wood frame on site. And that's because of all the redundant surfaces, floor to floor, wall to wall. But there's much less waste in production in the plant to counter some of that. But again, it's a big box. It's a lot of expense to get a permit, a trailer vehicle, get it down the road. So, you have countering forces for helping and reducing cost and adding cost, but generally it's a way of really reducing trades. And then you can have panels plus cores, where you build the core in the plan and then you use panels for the rest of the wall. So on the left is a pre-made bathroom, on the right, pre-made kitchens, and you would just drop those in place. Here's an example for an ADU, accessory dwelling unit, where one company has two cores, one for the bathroom, one for the kitchen. And because both cores are about 8.5 feet wide or less, they fit in the back of a normal truck. You get rid of the permit, you get rid of the trailer vehicle, you can ship it incredibly lower cost, and you get like maybe 10, 12 trades working so much more efficiently in a plant with better quality control on the most critical spaces that need so much work and so hard to do in the field, done so much lower cost. And then the other 5 exterior panels go on to create a complete building on the outside. 4 more panels complete the framing of the walls on the inside, and you have a building. And so the spaces that are just open volume can be cost effectively applied to just the panels. But you see, there's just ways of doing mixing and matching to really get this optimized. And the last option is 3D printing. And this is one where it's 3D printed in a plant. This is 2 halves that are dropped together on site. And so everything's done in the plant completely, except for whatever foundation work is needed on site. And here's another application where you build on site, where you have like a big printer that prints concrete dropped on site, leveled, and then have a whole system of concrete being mixed going through the system. And it can do anything you want: curved walls, straight walls. It can work 24 hours a day, just printing, and no labor except for the operator running the equipment. Now, what's interesting is to start to see some of the large national companies, production builders, looking into this. I wasn't sure what to expect from 3D myself, but here you have Century Communities doing a project with 72 homes on the left, and D.R. Horton doing another project in South Florida. So we'll see what happens with 3D. All these things have to compete with each other, but you see what the options are. So the big question then is, why are systems built homes not scaling? And the numbers are pretty amazing how low they're not scaling. This is a kind of comparing the market penetration for systems built single family homes in Sweden, Japan, Germany, UK, and US. And of course, you can see US is obviously incredibly lagging, only about 3.5%, I think today, maybe 4% since 2018, but hardly moving the needle, where other countries are going from 7 to 11, UK, 15 to 20, Germany and Japan. And then you have the poster child for complete transformation to systems built. In Sweden, 85% of the homes there are systems built. Again, single family homes we're talking about. And they've just taken over. And for obvious reasons, everyone in Sweden sees these homes and go, I wouldn't buy a site built home. This is crazy. The amount of quality, performance, and we'll talk more about that when we show examples. They just wouldn't make that compromise. And I think our industry has a lot of delusions about how much customization is needed. I keep countering a lot of the builder friends I have that it is a delusion not for the luxury homes and the higher end homes, for the mainstream buyer who wants to get into a house and not be financially burdened. You're way over customizing the product you're providing. So why doesn't it go to market in the US is the key question. I spent my life managing change and learning about change, and having the privilege to make so many mistakes trying to transform markets to innovation with Energy Star and Zero Energy Ready Home. And when we were successful, I was militant about wanting to understand why were we successful, because so much of what we were doing was by instinct and not by a repetitive process that we could do over and over. And my studies have led me to a framework for how we scale. And one of the most important resources that's a partial look at the framework is a book, Inside the Tornado by Geoffrey Moore, mostly focused on the technology industry, but everything I believe that's covered is just as relevant to construction. And the essential aha from that research and analysis that is done there in that book is that we normally, when we map out a market diffusion curve for a new innovation, we would draw this S curve that you see here. and market penetration on the vertical axis and time on the horizontal axis. And you start off slow, just basically dealing with early adopters who will embrace new innovation. And it's a long slog to get to the mainstream users. And then you get to the laggards. And this is supposed to be how it works. Well, the research and the analysis from Geoffrey Moore suggests something that's very different. That in fact, if we look at the profile, the two main demographics involved in the diffusion curve, early adopters and mainstream users, early adopters are unique. They accept higher costs. They'll gamble on the future rewards. And when I say rewards, I mean both cost and the value equation is so enticing to them, they go. They also accept uncertainty. They're venturesome. They'll cope if things are not going as planned. They'll accept setbacks and figure things out. And they accept high friction. They don't mind working in innovation cliques to work around issues, and they'll deal with complicated transactions. They want to deploy the innovation. Then when you get to the mainstream user, you could not be more diametrically different. They reject high cost. They discrete any new idea that isn't obviously just so compelling to them. And they will not pay an extra penny if they don't understand the value and it's not lower cost. They reject uncertainty. They'll deliberate forever if they're not sure. They resist anything that's confusing them. They want proven solutions, and they reject friction. They want, give me the whole product solution. I don't want to have to figure anything out. I don't want to form a click. I want simple transactions. Everything about them is different. So as a result, this is a myth that you have a smooth transition from early adopters to mainstream users. In fact, there's a chasm. That's the reality, that there's a big kind of chasm you have to cross before you can get to the mainstream user. And if you don't cross that chasm right here, which is the whole focus of scaling, then you go flatline. So when you see flatline for SIPs or for modulars or for a lot of these systems built options today in the market, it's because they're not crossing the chasm. They're not addressing that incredible challenge to get to the mainstream user. So thus, why are homes not scaling? They failed to cross the chasm. They don't optimize the cost plus value equation in a way that it's absolutely understood and compelling. They have way excessive friction and way excessive uncertainty. And I can virtually map out any company I see that's system built, and I will essentially benchmark them against these three chasm factors, and I can always accurately, I feel, predict if they will scale or not scale. So when you rethink scaling systems built homes, it's just a response to that reality. You have to cross the chasm. You have to optimize cost and value in a way that is so transparent to the end user. And you have to figure that out. And you have to mitigate friction and you have to mitigate uncertainty. This is what you have to do. And then there's one extra part about scaling is there are bright spots out there that inform a path for how you can do this. You have models you can copy. They're motivating because they're doing it and they're accomplishing, if not all these aspects of crossing the chasm, critical parts of it. So you want to leverage those bright spots, those areas that are truly demonstrating there's a path to addressing each of these challenges. So let's look at them individually and then look at actual examples where things are being done that create a foundation for scaling in this country. So in optimizing cost and value, one of the most important elements that's missing from the industry is systems built, optimized designs. A lot of the panel companies in particular, and even some of the modular companies, are really guilty of this. The builder brings in the plans, and then the plan has to figure out how the hell am I going to get our plan to be able to make that custom design. It just adds so much cost to the site systems built process. What you have to do is develop designs that are fully optimized for everything about how that plant works and all the elements that have to be followed to reduce and minimize cost. It doesn't change the quality of the design. It's just a set of factors you have to integrate if you want to minimize cost. And then, of course, you can minimize cost by using more advanced production. It gets higher quality at a less resources. That's just going to reduce cost. And there's a whole array of different amazing things being done to really improve production. A lot of offsite plants today are just really building indoors and don't have anything more sophisticated than just a kind of a line that that the product can slide down and go from one station to the next. So there's a lot of advanced production technology. Like I said, you look at an advanced automobile plant today, and it's just a stunning amount of efficient systems with hardly any waste. And then one of the biggest challenges is translating all the value when you're done with a systems built product. What is the true cost? So often that's missing. I'll talk more about that. And even messaging all the advantages in a way that the end user understands. There are killer apps also for using some system building solutions in part just to address really key challenges or pain points in the industry. And when you create that experience using the systems built product by the builder, then they're willing to move into more and more use of that systems building option. And then mass customization. Again, we just over customize way too much. So let's look at next, mitigating friction. We want to make sure that if you deliver a product, that you also have a solution so the builder doesn't have to fight to find trades that know what to do with it, or the trades that have to then come in and install the electric, the mechanical, the plumbing. You have to make sure that all that is not a friction point for the builders. The best thing to do to mitigate friction is have setup services, so the builder's not required to find someone that knows what to do with that panel or set up the module. And then whole product solutions are always your friend. Whole enclosure or finished home, or companies can be vertically integrated where they take the builder out of the equation and they build, they develop the land, they build, and they manufacture the home. And that's again the model you'll see in Sweden, and I have one example here in the U.S. where I think maybe just selling to a builder is too difficult, and you have a better product and the builder's not vested in the construction; they're completely outsourcing it. So maybe you need to be, in some cases, vertically integrated. And then uncertainty. One thing is, the system build world has, I think, compromised a lot on the design side. It's time to integrate world-class architects to create these pre-designed homes that break this uncertainty that a systems built home will be just as aesthetically pleasing as a site-built home. And also backing up what the site builder can't do. You can build to a level of performance they can't, quality that they can't, and cycle time that they can't. I'm not going to talk more about that because of time constraints, but it's amazing how under warranted the system built home really is. I'll mention a little bit about retail centers and how the Swedes do it, and also getting people to touch, feel, and just see the innovation. When I watch a SIP home be assembled, it's so elegantly obvious how much less risk that is for everyone involved, the builder, the homeowner. And when you just see the quality of the product and what it looks like going in, it's just nothing like a framed home. So last one I want to mention in detail is leveraging bright spots. They give you direction, hope, and motivation because they're getting it done either in whole in terms of scaling or in parts. They're addressing the friction, they're addressing the cost and value or the uncertainty. And the key question is what's working? How can we do more of it? And look around the marketplace rather than reinventing a whole new solution. And so let's look at individual ways that we have bright spots and examples that show we have the scaling opportunity. And the first I'll talk about is plant prefab in California. Their basic product is zero energy, zero water, emissions, waste, and it's a super environmental home. But they add this world-class design, which is, to me, one of the unique things about them as a bright spot. You get the benefits of their factory production, but it's not a very advanced production line from what I can tell. They have these optimized designs for their product, which are critical, but they have the world-class design that makes them, desirable to their buyers, I believe. And it's a whole product solution, I think, except for the foundation. And they have all sorts of linkages to set up solutions to help you get their product on site installed. So, if you go to the web page, you have all these architectural choices, and they pick, again, world-class architects to take their product and using the constraints of what are modules that can be dimensions for shipping and spans and so forth, they come up with designs that have no compromise with the best site-built homes designed by architects. And so they take all that uncertainty away. And then, of course, you walk through these homes and all the quality advantage starts showing and the comfort advantage, and they're just beautiful homes. So this is one great bright spot, I think, about how to integrate world-class architects. Then in terms of advanced production, the most advanced I've seen, and we'll see how much difference this makes, is Autovol. They're in Nampa, Idaho. They had this amazing plant. They only opened about 5 years ago. They have 53 six-axis robots that are amazing, all software enabled. They can, on the fly, almost make any tweak and innovation to the product. But the plant's amazing. You have all the robots in the center of a square donut and all the cutting machines and flipping machines around the outside of the donut. And they make all these amazing modules. Now, what they say, I don't have the data. I'm being real frank with you, but if you read their content, is that the cycle time for building multifamily homes is about 40% less. That's a huge benefit. That's right there, justifies almost any cost premium. 160 modules in 3 weeks. And their killer app for them is multifamily, because modules for multifamily are so ideal. You just drop them in and you can create these beautiful apartment buildings. It's so suited to that particular building type, modular in particular. They about 20% cost savings in high cost markets like California, where they serve. So the plant's in a low cost market for labor and building is Idaho, and they ship it to California for about $100 a square foot. And again, the quality, the accuracy, the strength of the product will be superior. But this is, if you want to look for someone who's taking the advanced production to the max, this is a pretty interesting bright spot. We'll see how successful they are. The Swedes believe that robotics is not cost out. So we'll see in this case, for particularly multifamily, because the Swedes are doing only single family, if it does cost out, because modular is so ideal in multifamily. And then in terms of optimizing design, I love this. Howard Building Science, Rob Howard's a good friend and a great model for everyone to follow. He's just such a compassionate, amazing builder. This is workforce housing. This home's under 200,000. It's a SIP home. It's incredible quality. It's not cheap siding. It's not cheap cabinets and cheap appliances and cheap equipment. It's a $200,000 home that's well equipped because he's saved so much money with a SIP optimized design. Now he also has a 2-story, I think 1,500 square foot model and other models. But if you look at this model, I'll just show you one example how optimized it is, and it follows suit in all the other products. And then I'll show you the cost equation later. But why it's optimized is the simple roof, simple footprint. The spans are perfect for the panel. The post and beam location are ideally set up so they fit right in the wall locations. No exterior wall plumbing. 4-inch walls outperform 6-inch walls, so he gains 2 inches around the perimeter for about another 20 or so additional square feet because he used SIPs versus conventional framing. He would have needed 6-inch walls. He uses all the attic volume for storage and or vaulted ceilings, and he has 2-foot dimensions so that it's right in line with what the plant makes. And here's the product, and I'll submit it's just a simple box. It's beautiful because of proportions, because of simple details and trim that work and color. He does everything right. And so you go inside, again, it's not cheap cabinets, it's not cheap appliances. He has really good quality washer dryers and finishes. And here's the basic layout where you can see the posts in the middle of this wall over here and in the center of a perfect location so they can support the ridge beam and then the simple roof. You can look at the bathrooms and see all the plumbings on interior walls. And it's just, everything's optimized. And then here's the section to the home and the roof plan, again, where you can see how simple it is, ideal for SIPs. In the section through the house, you have half the house has storage above the bedrooms, the other half the house, which is the kitchen, dining, great room area, has vaulted ceilings, all adding extra value at no cost because the SIP allows you to do that because it's fully insulated versus an attic where you lose that space. So the other bright spot is how do you translate that value and explain the cost and value? And for the Structural Insulated Panel Association, I was contracted to develop a tool called the SEPA True Cost Bidding Tool. And what we did was we took all the interrelated costs when you use SIPs, time, construction. There are a lot of interrelated costs that happen with structure, with insulation that already is included with the panel, airflow control that's already included with the panels, the finishes that are easier to do, mechanical, electrical, plumbing, and all the advantages of quality and lean with less waste, less rework. And all those costs are factored in. And then value adders, the much improved quality, resilience, structural integrity, dimensional accuracy, that's worth more than zero. And then the added volume. If I'm adding 20 square feet in the floor plan because of 4-inch walls instead of 6-inch walls, and it costs $200 a square foot, that's $8,000 right there. And I get all that attic living space. If I use it, in this case, I use the storage and the vaulted ceilings, adds a lot of value. Storage might be worth $30, $40, $50 a square foot. So that's another $15,000, $20,000 of value. And then it may help you qualify for incentives like Energy Star Zero Ready, where you might not. With conventional framing, you can account for that as well. But when you do this true cost accounting and not just comparing a bid package result, framing package versus a SIP package, you get to the right answer. So that's what we did on this project. We compared what would he have gotten with a framing bid versus a SIP bid, and it wound up that the SIP versus framing, if you simply look at the bid packages for each of those, was $14,000 higher. In this chart, the horizontal line here in the middle is the frame cost of framing. If SIPs is higher, you go above. If it's lower, you go below. It's $14,000 higher, which would mean, in effect, this is why builders are getting sticker shock when they get a SIP bid. They compare it to the framing bid, they go, it's $14,000 more. That's a 56% premium. I'm out of here. Now, in the case of Rob Howard, he's really an advanced builder. He's the early adopter. He's willing to do the analysis himself, to figure it out. And this is what he figured out, that he shouldn't have to figure out, that the SEPA tool, bidding tool, figured out after the fact, which is that, in fact, when you looked at all of his costs, the savings on insulation, on air sealing, on rework, on waste, on time, on everything he was saving, it netted out $400 lower costs to do SIPs and framing. Plus, he added $7,000 in value because he had a storage loft because of the space he could use above the bedrooms. He had vaulted ceilings. He had more square footage on the floor. He had absolutely wildfire resistant home and higher impact resistant construction. And he had much more high quality construction. So all that extra value and cost savings netted $37,650 cost advantage. That's why he did it. But he had to figure it out himself. So the purpose of the true cost tool is when you get a SIP bid, you see the true cost comparison. And now you can make a much more informed decision. So it helps translate the value. And then when I'm also really, when I work with the SIPs industry, I always wonder why they don't really push some of the killer apps like helping builders go from vented attics to unvented attic. When you have a vented attic, you have a couple of big issues. First is when you look at the red lines shown in this diagram, those are the air barriers. So outside it's the sheathing, and then it's the concrete below, and then it's the walls and the sheathing and the windows, and then it's the drywall at the top. And what you notice is, oops, I'm missing the air barrier on the top side of the insulation. That's why you need so much more attic insulation than you do in the walls, because you have no top side air barrier. And so that's one problem. The second problem, very often we stick the air conditioning and heating system up in the attic where it's 135 degrees in the summer instead of 90 degrees as it is outside. And it's just as cold in winter as it is outside. It's a horrible place for a heating and cooling system and the ductwork. So The killer app is use a SIP attic. And what happens is you go in faster, so you reduce cycle time. You have all this additional conditioned space for extra rooms or storage, or having your heating cooling system in a conditioned space, which will make them tremendously more efficient. You have more comfort in the house. You have a stronger home, and you have a more resilient house. No fire embers can't get in during wildfires into your attic the way they can with a vented attic. And all the cost savings have to be accounted for. You don't have a ridge vent, a soffit vent, or a gable vent. You don't have all the plethora of air barriers and air sealing details you got to do with a conventional vented attic. Well, the time you're saving is money. So, very often we can move an industry to market by at least getting its killer app embraced by the industry because of the compelling business case that you see here. And this is a SIP attic, and this is what the space can be. That is serious value right there. If I'm getting space like that, I'm getting 800 square feet at $300 a square feet, and that's, that, what am I, it's like $100,000. It's just $250,000. I'm adding tremendous value. You're blowing away whatever premium that you think you're paying for the SIPs if you take advantage of optimizing your design for the system built technology. Another good example I like a lot is Simple Homes in Denver, Colorado. I think it's a pretty amazing company. They use a frame panel construction, but they do a great job optimizing cost and value with factory production and optimized designs, and they mitigate friction. They have a whole product solution. They're not going to just send you panels and you go figure out what to do with them. A big issue again with the SIPs industry. That's how most of the SIP companies work. They'll send you the panels and you got to hope the electrician knows what to do with them. The framer will install them. The framer will do the interior walls, even though they're losing the like 2/3 of the project to the SIP company, and they'll still work with you. And uncertainty and issues, that is creating so much friction and uncertainty for the SIP industry, and really explains for me a lot why it will struggle to scale. So this company says, no, whole product solution set up, we'll give you great designs. So this is their product. It comes to site in these beautiful panels. The quality they do in the plant is so much better than the field. And they have in the plant, they have the weather barrier, the windows, they have the floors, they do the interior walls. It's the whole product, it's the whole package. And this home is a good example just how good their designs can be. I think this is a beautiful, simple cottage design. I think the floor plan's great. It's all built in a plant. I watched their 4-minute video of their video showing the installation of a home just like this one. 4 hours is all it takes from foundation to a full enclosure and interior walls was 4 hours. It's just, you can't believe how much cost savings that is. So this is an incredible bright spot for me as well. And then mass customization. I just don't know how the systems built world can ignore this, how powerful this is for taking their product to the next level. This is a site built example that would be perfect for systems built, modules or panels. This is a good friend of mine, Digibuilt. They used to be a developer builder kind of company, and they would use the system over and over. You see the 6 building blocks are A, B, C, D, E, F. They form a floor plan like you see here. For the first floor and for the second floor, you use these same blocks over and over. They use a world-class designer to really optimize design and the health aspects of the home and lighting, color, landscaping. They get all that stuff integrated. You see how beautifully they're creating the narrow space between the home to be actually landscaped and a outdoor living benefit that most site builders ignore. So it's beautiful how these building blocks assemble to these beautiful floor plans, all optimized by the designer. And then you have the kitchens and bathrooms are all the same in every home. He's not building dozens of different kitchens. You can change the counter, you can change maybe a cabinet finish or a backsplash, but minimal choices, and you get these beautiful options. So with those 6 building blocks, you have all this diverse architectural options as the home buyer. And you have 2-3 choices on the number of stories, the roof truss configuration, pop-out windows, front porches and siding, trim packages and color packages. And look what that produces. That's what mass customization does. And this is the actual product finish. And I will ask anyone to tell me if that looks like a track built production home subdivision. That looks almost like a custom home subdivision, because mass customization with an expert designer produces this outcome. And this can be done so easily by offsite construction. And a final word about mass customization, since I get so much fight from my builder friends about this, is I saw this article, I thought just put it together for me. Why does designers get bold with kitchen colors? The reality is that we feel we have to offer all this insane amount of customization when what's going to happen is that whatever decisions your overwhelmed customers agonize over today, and they'll cry in the showcase centers where they're trying to make all the choices out of exhaustion and out of just stress trying to get the right choices. They would make a completely different choice in a few years is the reality for whatever they do in that process, because everything keeps changing. And to put that customization in a situation where the affordability is off the chart and mass customization can make things so much cheaper, it's crazy. Enough about that. Okay, 2 bright spots I'll wrap up with. And the first is the Swedish factory-built homes. Since they have 85% of the market, maybe we should see if there's something worth emulating. Notwithstanding, I understand Sweden's not a big housing market. There's a lot of homogeneity and advantages with the codes, but it's a lot more than that. This just shows you all the companies and by the number of homes they built a year. So you have some companies up to 1,000, about 650, a bunch of 500 and 300, and they do about 80%. But even the small guys do pretty well. A little less sophisticated production maybe. But the main concept with the top 6 companies is always the same. At one end of the factory, you have the logs come in, Skanska and others. They mill the lumber, produce the lumber at amazing quality. Then it goes through the production plant. Out come the best built homes in the world, stunning homes that come out, and they do it all. It's the whole crossing the chasm package. They optimize cost and value with these amazing optimized designs for their production process. They have optimized performance, passive house level efficiency, optimized quality. They're all not only how they build, but all the accessories and the cabinets and the fixtures. Everything's amazing what they do. They use mass customization and advanced production methods, then minimize friction with a whole product solution. They're vertically integrated. You go to them, you buy the home at a retail center, you customize it with them with the choices you have. They then schedule the construction, they build it for you, and it's amazing. And the uncertainty goes away because you have these world-class designs in the retail centers where you walk, smell, feel every aspect of the home and see this is transformative. This is a whole different way of construction from anything else that is older and wasn't built in a factory. So here's the process. Basically, they take a design and optimize it for simple. The forms are boxy but beautiful by details, proportions, and good quality materials. Unvented attics are never sacrificed. That is an asset they would never give up. They use that volume always to enhance how it lives, and they use quality details and components, and they mass customize. They get many styles with basic building blocks. So here's an example of a product that might be an entry product. So it's about a 1,400 square foot home for 186,000. These are about 5-year-old numbers, so things have gone up a bit, but still, this is passive house level, triple glazed window, incredible quality materials inside, incredible quality materials outside in components, and it's $185,000 soup to nuts. Then you step up. This is a little bit of a move-up product. It's $169 a square foot at $280,000 complete. 4-bedroom, 2 baths. Again, beautifully designed, amazing windows. And then, of course, at the very high end, it's about $239, $240 a square foot, about $400,000 plus for an 1,800 square foot house, 3 bedrooms, 2 baths. But when you go through every aspect of the detailing, the finish, the quality, the fit, the trim, the performance, passive house again, amazing windows, these triple glazed European windows that are beautiful. This is incredible for the price. And they do it with advanced production. In the factory, they've just figured out the whole way of engineering how to optimize the process and the team. They really focus on product and customers, just like like a Toyota plant would be. The small producers can even work with this system, and they don't believe in the robotics. It doesn't pan out for them there, but they do very advanced cutting machines and flipping machines. I mean, this is what their plants look like. They're engineered for absolute optimized productivity. Everything moves along the line. You see 8 people are working this plant. That's all it takes to produce 500 homes a year. It's just stunning what comes out of the plant, all with 8 people and very simple systems. And again, look at the quality of the wood that's milled in the plant, and look at the quality of the framing. And it's all being done with equipment, automated. It's not, very little hands are touching the product to make it and assemble it. The same with the roofing systems. They use advanced lasers and other technology to make those. And like I mentioned, passive house level performance. So it completely differentiates the new home from buying an older home in Sweden. This is, every aspect of this I can go through, and I normally do in our presentations on high performance, but it's, it's thermally broken. It's super insulated at every aspect, windows, the walls, the attic, the sloped attics, everything about it is super built. And then they've engineered the whole site process for maximum quality. Most US plants, the quality is only the border of the business is around the plant where they manage the quality. When it goes to the field, the plant is not in control. In Sweden, they own the quality in the plant, and then when it gets shipped, they own the quality on site. They have a whole system of how they set up scaffolding and the cranes and the rigs they use to install the panels on site. Same quality as in the plant in the field. That is so different from American site-built homes. And this is where it completely differs. They have the retail centers where they take all the uncertainty out of what you're getting, the quality of what you're getting. They translate it in brochures beautifully. And you see these beautiful homes again. And it's just so easy for them to sell to mainstream buyers. Enough. Last bright spot is Onyx, kind of a newer company, currently based in Florida, also moving to Texas as we speak. And first thing I want to do is, again, this is the message when you go to the website. We believe the world demands that we build different and build better. I go crazy when companies overcomplicate their message. They had it. Just take out these words. We build different and build better. Go into 6 words from like 12 words. So that would be my recommendation to Onyx is just, you had me at we build different and build better. You didn't need all the other words on the website. But what a company. They optimize just like the Swedes. They have their formula and their way to optimize cost and value with optimized designs, mass customization, advanced production, the mitigating friction with a whole product solution. There's nothing missing. You get the whole soup to nuts home from beginning to end, set up services, and they're vertically integrated. They develop, they build, manufacture. So that's why they can control things at a much higher level. And they mitigate uncertainty. They used to self-insure the homes for the buyers because there was so little risk, they were willing to do it. They found an insurance provider who understands how little risk are in their homes, and their homes are being sold at a very substantial insurance discount. And they show the model homes explain how much value there is to this factory built home. So first, I want to start with build different and better by, at the very beginning, completely rethinking the enclosure. We're building homes in an incredibly hot, humid region of the country, incredibly disaster-prone region of the country. We want to minimize structural risks and construction costs. And so when you compare wood to concrete, it's a stunning difference in which product delivers on all things that you would care about. If you want low, high humidity risks. You want no chance of mold, 0 chance of rot, 0 chance of dimensional and warp stability problems. If you want no expansion and contraction issues that may create cracking or seal problems with vinyl windows and wood frames, wood is a complete no or an X on all those attributes. Concrete is crushing them. addresses all of them almost bulletproof. If you want disaster resistance, high impact, pest, wildfire, wood is completely vulnerable to all those. Concrete, again, completely mitigates those risks. And do you know, in Florida is like, I think, the highest termite cost state in the country. It's over $1 billion a year of termite damage is done every year. You don't need to have all those chemicals sprayed around your house. You don't need to pay for the pest service. You don't have to pay for the higher insurance costs. It's just incredible how much resistance the concrete gives you. Structurally, the product performance doesn't vary with orientation of material, no sustained load creep. And then on construction costs, you have less job site waste, less labor and job site protection. The materials doesn't have to be done. So wood, no, concrete, yes. It's just, sometimes when you step back and say, what am I trying to do here? You start to ask questions. Am I even using the right material building with wood like all the other builders? And they said, no. So I visited a plant last year, and these are my shots from that, but it's a completely robotic operation building the walls assemblies. They basically, this is a robotic system that sets the forms for all the openings and sizes the panel based on the CAD drawings, and it just moves everything automatically. And so you create these forms for pouring the concrete, and they're 2-inch slabs that are poured, and then they're steam cured to 8 or 10,000 psi. And then you have two sandwiches come together to create the wall. So you see them putting the insulation on the panel on the right that will be flopped over on the panel on the bottom, or a different panel. And then you create your wall panel. So you see on the right there again, the panel on the right will be flopped over the one on the left. And it creates a panel like this that's sealed on the edges when it's done. And it has all the wiring, the plumbing, whatever you need. And it's then cures to, again, 10,000 psi. It's bulletproof for moisture. You can't have any moisture flow. You can't have any bulk moisture issues. It's just a incredibly strong product. It's impact proof, and it's stacked and sequenced, ready to be installed on site. And then they build the pods for the bathrooms in a separate plant, and they just form them and drop them on site. And basically, it's a finished bathroom that is dropped on site. I like to see them get some more advanced finishes and designs in the bathrooms, and I believe they're going that direction. Then all the interior framing and the roof framing is done in a separate section. They have a rolling machines that takes the steel and it bends it into channels, and then it cuts it automatically and creates all the pieces they need. And there's more people working here, obviously, than in the robotics section of the plant, but they build, again, the interior walls and the roofing. So what you're seeing here is the foundation. These stem walls are made in a factory and dropped on site. And they do what other builders don't do. They raise the house way above the base flood elevation, way more safe against flooding than typical builders. And so you have the stem walls, and even the entry steps are made in the plant. So you see those entry steps, stem walls, and then they drop the factory-made walls on the foundation. And then even these interior stairs, they're made in the plant, poured concrete, and just dropped on site. And then they build the interior walls out of steel. You have your finished homes. And their basic construction cycle is so much less than this typical site built. Is about 22 subcontractors in 8 months. And as they show, it's one system in 30 days. The company may hire, I think, a painting crew to come in and a drywall crew, not much else. Otherwise, everything else is done by the company. So they have I would estimate about $45 million annual revenue increase just from the added productivity of the plant that can produce that many homes in 30 days, produce a home in 30 days. Plant can do, I think, about 1,000 homes a year. I think they currently at a plant might be doing 500 homes a year. Again, it's 30 versus 60-day cycle time for another production builder. Again, 8.6 months for the industry at large. If they have a 15% profit margin, that's where I can calculate about a $45 million advantage every year to having additional production. But $600,000 is our average retail price, right in line with other new products of the same size and quality. So this might be one of their neighborhoods that you go to. Again, you can see it's a traditional neighborhood. The only difference is the homes are higher above the ground than most other builders, so they're flood protected. This is a home. This one's starting at 300,000. This is a 2-level starting at 500,000. This is the inside. It's all hard surfaces, which enhances health. Again, high performance, bulletproof, airtight, amazing ability to control moisture and much better. No moisture issues in the assemblies. And you get a lot of different architectural looks out of the home. But essentially, this is what's happening. They're optimizing affordability because of just the insurance premiums dwarf savings, probably dwarf the energy savings that most high performance builders get. The sales process is so simple. There's so little choices there. It's completely minimized to avoid cost. So because of that, they haven't over customized their homes, they're able to offer so much more value at a better cost, and they sell everything they can make, as far as I could tell. They have ultra low utility bills and amazing ultra low maintenance. There's like nothing to do with the basic infrastructure of the home. It'll be cosmetics that come up. It's such a bulletproof home. On wellness, you have completely maximized resistance to moisture, hurricanes, tornadoes, floods, termites. You even have almost a safe room or a safe house in a tornado. The bathroom itself even has a concrete lid, so it's a complete safe room, and the house itself is virtually almost bulletproof. And then of course, the indoor air quality is so good in these homes. And then in terms of future value, the quality, the durability that will persist, and all the built-in smart features they can do. And I estimate, this is like so much incredible value when you add it up. Just the utility savings over 30 years, the insurance savings over 30 years, the maintenance savings over 30 years. This is hundreds of thousands of dollars of added value. So I'm done. And what I just want to leave you with, if we're going to rethink scaling systems built homes, everything I've researched and studied tells me if you want to scale, these are the 4 things you got to do. You have to figure out how to optimize cost and value so it is crystal clear to the mainstream buyer, not something that Rob Howard had to figure out on his own, making his own decision to use SIPs. You have to mitigate friction. You cannot expect builders to have to go ahead and find the contractors to fill in the gaps and to figure out how to use your system and understand it. That's not going to happen beyond the early adopters. You need to mitigate uncertainty. People have to really understand I can get the aesthetics I want. This is superior quality in ways where you back it up and don't make it any uncertainty that you have the quality that the site-built world can't deliver. And you have to do more of what's working. Look at the examples out there that are absolutely demonstrating incredibly effective ways at doing the first 3: cost and value, friction, and certainty. So I'll leave you with that, and I hope that makes sense. And Mike, if you have any questions, I have about, at most, about 7 or 8 minutes. I can do questions.
All right, Sam, thank you much. We'll get to as many questions as we can then in that time frame. We've got a question from Shanti wanting to know how will insurance costs impact housing costs? And are there systems built approaches that can address these? Now, I think you kind of hit a little bit on some of that disaster and resiliency, but talking about insurance costs impacting housing costs?
Oh, sure. Again, what Onyx used to do is self-insure their homes. They go, I have no risk here. I'm not going to have any cracking drywall. I'm not going to have any damage to this home in a hurricane. I'm using tempered glass that's incredibly resistant to impact resistance. On these walls, nothing will happen. Notice I have the hip roofs, unvented, so wind can't get in, uplift, destroy the roofs. They said, this is crazy. The insurance costs are like 8, 9, 10,000 a year. We'll self-insure and save them thousands of dollars. Not wanting to be an insurance company, they finally bring insurance companies out to see this kind of construction. An insurance company understands in a nanosecond how little risk they have, and they're able to negotiate a better package for the buyers and get themselves out of the self-insuring business. So insurers eventually will come around and realize that they have to address their price to the risk, because otherwise companies like this don't even want to give them the business. So yes, it's a great question, and thank you, Shanti, for asking it. I think, though, it's going to take a lot of education with the insurance industry to help them understand the real differences before they can adjust their business model and have different price structures. Or you can just be able to qualify much more easily for the Institute for Business and Home Safety's Fortified Home Program, and that will get you a 25 to 40% insurance discount just by doing that. And again, the Onyx Home, for instance, in Florida, would instantly qualify for those discounts by virtue of that. And that may have been the system they used to get it.
We had a question from Lauren. Beyond continuing to educate, providing the proper sales service and support, showing successful case studies, what more can be done for systems built to gain more recognition in the US market? And kind of conversely, what has made systems built so much more successful in some of the European markets?
What I'll suggest in the European markets, it's made it more successful before getting to what can the US do, is I mentioned one of them earlier on, which is, let's say in a country like Sweden, you have all these companies are working with a homogeneous code and a different regulatory environment, and it probably makes it easier for them. So, and also I think the culture is different and the buyers' attitudes are different there. I don't think in this country there's been a lot of systems built work where, again, a lot of the early modular work was pretty much low end. You had the manufactured housing, factory made homes were very low end, and a lot of systems building was deferring to just lowest cost and lower quality materials just to try to get people to use it as a strategy rather than try to compete on other basis points. So I think Europe had an advantage that people came in with better strategies and for some reason understood ways to mitigate cost objections, uncertainty, and friction. So what the U.S. market can do, I think, is hopefully learn from this. You know, Katerra was a $2 billion disaster. SoftBank put $2 billion in plus other investors and got nothing out of it. And then you had Integra I thought a very good product, but they didn't reduce friction and they didn't have whole product solutions. They had to rely on getting individual builders to change their process and break their long-earned agreements with framing contractors to do their work. It was, I think in this country, it's going to be harder, but I think we know what to do from the framework I just laid out. And if you don't check every one of those boxes, cost and value, friction, and uncertainty, if you don't check every one of those boxes, then probably you're going to have a tough time scaling. And that always is not the wrong thing. I think some of the systems built players are happy with their niche market business. The SIP guys sell to their SIP buyers, the modular builders sell to their modular buyers, and they make a decent living. And so you have to want to really grow the industry. My point is that for the larger mainstream home buyer, I don't think they can afford traditional built homes anymore just by the numbers. And the only way to extract cost savings for that part of the market is with the system building. And I think, like I said, I think we know what to do. That's the points I laid out.
So we've got a question from Kim. Because modular factories are the hub in a spoke model, how can modular factories entice builders at the end of those spokes to become site prep contractors and then, setters and stitchers and warranty providers, especially for those who maybe are building one-off homes?
Yeah, that's a good question. By not owning the site part of the equation, that's where a lot of uncertainty enters. In the systems built world, for most products that aren't very small, except for very small panels, you have to have a perfect foundation. And by that, it's got to be dead level. You can't drop a module or a big panel and the foundation have dimensional variance that's very significant and expect to set that panel properly or module. So by not owning that process and having absolute control, which you can get the quality, you just have to be committed to it. And by relying on a contractor who's not being held to that kind of quality control to come in for your modular product or big panel product and expect them to change is sometimes a big ask. So it is tough when, and I think almost most of your effort has to be dedicated to getting the builder who's basically providing the foundation for the modular to build a dead level foundation, and also be responsible in the field for knowing how to make sure the marriage joints between the modules are very airtight. That's the one issue that's tougher. With modules, you can't lift them in place without a thick cable because they're so much heavier than a panel. So you have a thicker gap between the seam between the marriage seam between the two modules. And so it's a much more difficult air seal than a panel can butt right up next to it. Two sit panels are right next to each other, airtight. And so you have to get all those details figured out with the crew that you're selling it to. Even though the home's built in the plant and finished in the plant, it's not like you don't have things to worry about. And how do you get them motivated to do that is basically that they can build homes without trades, except for the concrete. They only have to have the concrete trade and some basic waste lines put in and electric power put in. But in terms of wiring the house and plumbing the house itself, I mean, all the trades are done for you with many modular products. So you have to have a builder who loves that kind of business model, doesn't have to hunt down all the dozen or so different trades and can just have the house dropped on and benefit from the cycle time advantage to the degree that you can get it. Some of the times factories with modulars homes can be backed up as well. So it's a tough question. I don't know I know a perfect answer to it, but they have to be motivated by that business model, not wanting to work with the trades.
All right. And do we have time for one more, Sam, or do we have to wrap it up here?
Do one more and we'll wrap up after that.
Okay. All right. So we do have one more, and I apologize to those that we were not able to get to your questions. I'll make sure to get those down and email those to Sam so he can follow up with you. So if homes built on metal chassis with axles were built to IRC codes instead of HUD codes, could that possibly overcome mainstream market resistance?
What a great comment. And I think it's a big part of it. There are a number of issues. Local jurisdictions are pretty much convinced that a manufactured house will be very limited value and reduce the tax revenues and might have issues during disaster events. Now, a lot of the problems with disaster events is not fair a reputation for that industry. It's so many of the homes are located in the absolute worst locations at low flood levels, base flood elevation levels. They're not built with better foundations. So it's not the manufactured house problem. It's that the foundations and or the siding of the homes often leads to them optically having more issues maybe during disasters. And so one, having parity with the IRC between manufactured and site built, yeah, I think that would be a huge, huge advantage to getting local jurisdictions to see manufactured housing as an amazing solution for attainable housing. But then there might be other factors. They may want to have homes that visually do not undermine property value. So they want maybe a more permanent looking foundation than just skirting. And they may also ask for certain architectural capabilities that, maybe a higher pitch roof might be an example of something that might be a requirement. But yeah, I think that would go a long way. If you could get manufactured housing built to the IRC and local codes could have certainty about that, that would be huge. There's so many problems because HUD code housing and site built housing don't even use the same metrics. One may use pounds per square inch, and another one is using a total overall some value that's completely different from that. And the building departments don't even know how to even evaluate the manufactured housing option. So we have to reduce the uncertainty if we expect manufactured housing to be embraced by local jurisdictions. So it's a great question, and it's a very insightful. In fact, the IRC parity would be a big way to start building that kind of acceptance. So thanks, Mike. It was another great day.
Yep, thank you, Sam. And that does conclude today's seminar. Like I said, I will get these questions that were unanswered over to Sam. But thank you all so much for attending today. Thank you once again to Panasonic Healthy Indoor Living Solutions and LG for their generous sponsorships. The next GBM is shorthand, but the next Green Builder Media webinar is going to take place in just 6 days. That's right. I'm going to be joined by Darren Waschek, and our topic is going to be water efficiency in the water energy nexus. That will start at 2 p.m. Eastern time. That's going to be next Wednesday. Until next week, stay safe, stay healthy, and take care, everyone. So long.